This lesson is about experimental probability. We'll work through some vocabulary and then run through an example. So if you're taking notes, make sure you include definitions of some of these key terms which will be revealed as the lesson progresses. To start with, each instance used in calculating probabilities is called a trial, and the outcome we're interested in is called the favourable outcome. The probability of an outcome can be measured using the relative frequency. And in fact, relative frequency means the same thing as experimental probability. So experimental probability is based on some sort of experiment, using trials and looking for favourable outcomes. The relative frequency, or the experimental probability, is the frequency of the event we're interested in divided by the total frequency, or the number of favourable outcomes divided by the number of trials. So we'll try to clarify this by starting the example. The masses of 100-gram chocolate bars are measured as they come off the production line, and the results are as follows. So if you count up the number of chocolate bars here, we have 19 chocolate bars. N is 19. This is the number of trials. The probability of a bar being underweight means it's less than the advertised 100 grams. And there are 5 of these. So this is described as the favourable outcome. In the case of a chocolate bar, it's not really favourable if you're getting less chocolate, but it's the outcome we're interested in for this question. So that's 5 out of 19. And the probability of a bar being overweight means it's more than 100 grams, and there are 8 of those, so 8 out of 19. 8 favourable outcomes divided by 19 trials. One of the main reasons for calculating the relative frequency from experimental data is that we can then use that relative frequency to predict the number of times an event will occur in the future. And when we do this, it's called the expected frequency. To calculate the expected frequency, we take our experimental probability, or relative frequency, and multiply it by the number of trials in the new situation. In our chocolate bar example, how many underweight bars would we expect to get in a carton of 2,000 bars? So our expected frequency is the probability of a bar being underweight. Now the relative frequency of a bar being underweight was 5 out of 19. And the number of trials now is 2,000. And we type this into our calculator, we get a result of 526.3 to 1 decimal place. But of course, when we're dealing with chocolate bars, we need to round our answer to the nearest whole number. So it's approximately 526 chocolate bars. Finally, we're asked how many bars would we need to buy to end up with 30 overweight bars. So this is looking at the question in a slightly different way. We want our expected frequency to be 30, and the probability of a bar being overweight is 8 over 19. So what number of trials will result in a value of 30 when we multiply by 8 over 19? If we use a bit of algebra here, we're looking for a value of x that will make this equation true. And when we solve this equation, we get a value of x as 71.25. If you're not sure how I achieved that answer, you probably need to do a bit of work on your algebra. Now, just be careful with your rounding here. If we round to the nearest whole number, then that gives us a value of 71. But in this example, because we're trying to ensure that we get 30 overweight bars, we don't want to round down. In this particular instance, we need to round up to make sure that we get our 30 overweight bars.